For this function, we want to determine the local max and minimum points and the intervals where the function's increasing and decreasing. So it's first worth noting that we've got a domain restriction because the denominator cannot equal 0. So we just want to make sure we don't accidentally include 9 as a relative maximum or a minimum throughout this process. And then we'll compute our derivative using the quotient rule. So we've got low d high, derivative of the numerator is negative 18x, low d high minus the numerator, which is high, negative 9x squared, d low, derivative of the denominator is just 1, divided by the denominator squared. So we need to clean this up a little bit. I'm just going to reorder things. So we have negative 18x times the quantity x minus 9, and then plus 9x squared. Normally, I would have you factor the numerator. Because, though, this one, everything's raised to the first power, distributing really isn't that big of a deal. So I'll go ahead and choose to distribute. So we'll have negative 18x squared, and then we have negative 18x times 9. And 18 times 9 is 162, so that's 162, that's a positive, 162x plus 9x squared, all divided by that x minus 9, the quantity squared. And then we'll combine like terms, so negative 9x squared plus 162x divided by x minus 9, the quantity squared. Now, whether you want to factor now or factor later really doesn't matter. You're just going to have to factor that numerator at some point in time. I'm going to go ahead and do that now, and I'm going to factor out a negative 9x. So I will be left with x minus, and then remember 162 divided by 9 is 18. We did that earlier. So that's going to be a minus 18. So here is our simplified derivative. And then we want to find our critical numbers. So from here, critical numbers are where the derivative is either equal to 0 or where the derivative is undefined. Now we know it'll be undefined when the denominator is equal to 0. So where x minus 9 squared is equal to 0, which would be at x equals 9. Now technically that's not a critical number since it's not in the domain of the original function, but it's still worth noting because we will want to check the sign of the derivative on either side of 9. And then setting the derivative equal to 0 is just a matter of setting the numerator equal to 0. So in doing that, we'll have negative 9x equals 0 and x minus 18 equals 0. So we get these two critical numbers of 0 and positive 18. So taking a look at that first derivative test, we're going to test around these values. And again, I'm going to go ahead and include 9 here on my number line. The function's undefined at 9, and we could do a little bit more exploration to figure out exactly what's happening at 9. In this case, if we take a look at the original function here, there aren't any common factors in the numerator and in the denominator, so it's not going to be a whole at 9. It's actually going to be a vertical asymptote. But since you're not having to graph the function, that's not super important, although you might want to go ahead and make a little mental note here that we have a vertical asymptote at x equals 9, and we do want to check the sign of the derivative on either side. So we'll go ahead and use some test points, something smaller than 0, between 0 and 9, bigger than 9, and bigger than 18. And remember, we're testing these back here into our first derivative. Now, with regard to the first derivative, the denominator is x minus 9 squared. So that quantity is being squared. It's going to always be positive. So we really only have to worry about doing some testing in the negative 9x times x minus 18. I'm just going to jot that down here. Because yes, you could certainly go to your calculator for this, but it's really not too bad when you just think about, substituting negative 1 in for x. So negative 9 times negative 1 is certainly positive, and then negative 1 minus 18 is negative. That'll yield a negative. And then we move on and try positive 1. So negative 9 times positive 1 is negative, and then positive 1 minus 18 is also negative, so that results in a positive. Trying 10, negative 9 times 10 is negative, and 10 minus 18 is also negative, so that will be a positive. And then negative 9 times 20 is negative, but 20 minus 18 is positive. So that results in a negative. So again, you could be testing by hand or you could test using your graphing calculator, either way. And these first derivatives, remember, these signs, they are giving us information about the slope of the original curve. So this beginning minus sign, the first derivative is negative. That means that the slope of the curve is negative, which means that this function is going to decrease from negative infinity to 0. And then the function is going to increase, and from 0 to 9, now we're going to separate this out from 0 to 9 and then from 9 to 18. Because of that domain restriction, x cannot equal 9. So it's going to increase from 0 to 9, union 9 to 18. And then it'll decrease again from 18 to positive infinity. And if you want to say x is an element just to indicate that these are x intervals, always a good idea. And then we can also determine a relative or local maximum and minimum by looking at the slope. So looking at that negative first derivative and then changing to a positive. A negative slope means the function is decreasing, and then the positive means that the function is increasing. So then logically we would have a minimum there. So we'll have a minimum at 0. That's the x value of the minimum. I'll have to figure out the y value in just a second. And then also looking at the change in sign going from a positive first derivative to a negative first derivative means that function was increasing and then decreasing, which meant that we had a maximum. So our maximum is going to be at an x value of 18. Once again, we're going to have to take these x values and plug them back into the original function. So I'll just write f of 18 and f of 0 here as a reminder, because we're going to be finding the y values. So you can use your calculator for that, or if I just grab the original function here, which was negative 9x squared divided by x minus 9, then you can see plugging in 0 will just give me 0. So it looks like we have a relative minimum or a local minimum, which will be 0, 0. And then we'll have to go ahead and plug 18 in for x there. So negative 9 times 18 squared divided by 18 minus 9 gives us negative 324. So we have a relative maximum at 18, negative 324.